Good morning everyone. I, Liza Mallick, along with my team member Kunal Kaushik are here to present our BTech final year project which was accomplished under the guidance of Professor Gandharva Kumar Sharma sir. Our topic is Virtual Intelligent Assistant System as a part of a smart home setup. Here is a brief outline of the topics we are going to cover. First, we are going to look into a brief introduction followed by motivation and literature review. Then we will look into the problem formulation followed by the work done. Then we will look into the pictorial representation, limitations, and lastly, conclusion followed by thank you. We all know about the term called smart home system. It comes with numerous facilities to ease modern lifestyle. This technology aims for great advancement in the recent future. Machine learning has become a prominent technology. Our surroundings and lifestyle transmit a huge amount of data which can be put into analysis to optimize our lives with various technological facilities. A smart home should be able to understand its owner's lifestyle and adapt itself accordingly for efficient use of resources without compromising the comfort. Here are some of the literature reviews that we have gone through. There are several problems in today's smart home systems. Here we have worked on the following. Multiple sensors lead to high energy and data storage consumption. Generation of repetitive data consisting storage. Signal cross-connection between mainframe and remote devices. Conventional reminders use manual input. Predictive analysis using machine learning. Wouldn't it be amazing to get the sensor data without even using a sensor? This is what we will work upon. We will try to determine real-time temperature and sunrise-sunset time without using any kind of sensor, API or external source. Temperature prediction. Every smart home has temperature sensors to control the AC and heater. But these sensors consume electricity and has installation and maintenance cost. Weather temperature is dependent on month and the pattern repeats annually. Hence we will use machine learning to predict temperature based on sensor data from past years. Sunrise sunset time prediction. Outdoor lights are controlled either manually or by sensors. Manual control involves human error as we tend to forget to turn on or turn off the lights, resulting in electricity wastage. Deploying sensors also take up electricity and installation and maintenance cost. The state of light depends on the sunrise sunset time, as after sunset the light needs to be turned on and after sunrise it needs to be turned off. Sunrise sunset time pattern also repeats annually and hence we will use machine learning to predict sunrise sunset time based on data from past years. Here we look into the methodology. It goes as follows. Sensors collect data for a specific time at the beginning. Collected data is being analyzed. Suitable model is assigned to replicate the data. Further prediction is done using the model. Use of sensors is minimized. Energy and data storage is optimized. Less human error will occur in this process. In the block diagram, it shows that at first the sensor controls the actuator and meanwhile its data is being fed to the machine learning model to train on. Once it is trained, it can directly control the actuator without using any sensor. The data we used here is structured, hence we can implement supervised learning. Since this is a regression problem, we will test on linear regression and lowest regression to find the best fit. Linear regression is a simple machine learning algorithm that can be implemented on data that scales on a linear manner. It is used to predict the value of a variable based on the value of another variable. Based on the data, it works around a linear equation of a straight line and makes predictions with values satisfying that equation. Lowest regression works on polynomial data and is also known as local regression as it divides the data into subsets and analyzes them locally. We can control the size of these subsets to find an optimal fit. Lesser number of subsets will result in underfitting and large number of subsets will result in high accurate fit but will be computationally expensive. This is the temperature dataset with month, date and time as features and temperature as label. Month and time are converted into numerical values for better processing. When the data is plotted, it displays an inverse parabola. After prediction is made using both the models, we can see that linear regression does not fit at all. Lowest regression with fraction 1 by 5 is overfitting. Lowest regression with fraction 1 is underfitting. Lowest regression with fraction half is the best fit to the data. So this setting is chosen for the future predictions. The demonstration video of our working model.
AdVez welcomes you.
Real-time temperature from Google is 33 degrees Celsius.
Predicting current temperature. Current predicted temperature is 31.6 degrees Celsius. Turning on air conditioner. Connecting to air conditioner via Bluetooth on port COM7. Connection successful. Air conditioner is now on.
This is the sunrise sunset dataset with month and date as features and time as label. Month and day are converted to numerical values and time format is converted to float for better processing. The sunrise sunset data is being plotted. After prediction is made, we can see that linear regression doesn't fit at all. Lowest regression with fraction 1 and 1/2 is underfitting. Lowest regression with fraction 1/5 is the best fit to the data. So this setting is chosen for the future predictions. The demonstration video of our working model.
Actual sunrise time is 4:37 a.m.
Predicting sunrise time. Predicted sunrise time is 4:36 a.m. Setting reminder. Outdoor lights will turn off at 4:36 a.m.
Actual sunset time is 6:19 p.m.
Predicting sunset time. Predicted sunset time is 6:14 p.m. Setting reminder. Outdoor lights will turn on at 6:14 p.m.
Understanding owner's lifestyle using machine learning. Wouldn't it be amazing to get reminded about forgotten things without even setting a reminder? This is what we will work upon. We will try to understand owners' daily lifestyle and determine the things they have missed. In the block diagram, it shows that the system will collect data about the daily activities performed by the owner and train the model on that data. Once it is trained, it will predict the future activities to be performed by the owner, and in real time, if the activity doesn't match with the predicted activity, then it will trigger an alert. The data we used here is structured, hence we can implement supervised learning. Since this is a multi-class classification problem, we will use k-nearest neighbor algorithm. K-nearest neighbor is a distance-based algorithm. For an unknown point, it will count the number of nearest neighbors. The point will belong to the class that has highest number of neighbors to that point. The number of neighbors can be controlled by supplying a k value. The methodology is as follows. Collecting owner's activity data with respect to day and time. The KNN model will be trained on weeks of hourly based collected data. Once trained, it will be provided with real-time data to predict the activity the owner performs during that time. Meanwhile, the system will detect the activity the owner is actually performing in real time through image processing. If the owner's current activity does not match with the predicted activity, then there is a possibility that the owner forgot about it, so the system triggers the reminder. This is the activity dataset with day and time as features and activity as label. Activity and day are converted to numerical values for better processing. The activity data is being plotted. It consists of 2 weeks of data on hourly basis. The predictions are made by giving k equals to 3, 5 and 7, and it is found out that KNN with k equals to 3 fits best. The demonstration video of our working model.
Recognizing current activity. Current activity is exercise. Predicting current activity. Predicted activity is cleaning or laundry. I would like to remind you about cleaning or laundry.
Identification of remote devices. A smart home will have multiple number of devices in the network, so identification of each device is necessary to avoid cross-connection of signals. The methodology goes as follows. Sensors and actuators are given unique addresses so they can be identified by the system. Communication is mostly wireless and over Bluetooth. Hence, Bluetooth address and COM port numbers are used as unique addresses. The system pairs with the Bluetooth address and then sends the signal to its COM port, which is transmitted to the GPIO pin to which the device is connected. The system maintains a dictionary of all the Bluetooth addresses and devices connected to it. Hence, it can control multiple devices simultaneously. The demonstration video of our working model.
Advance welcomes you.
Light on. Light off. AC on. AC off.
From this we observe that each Bluetooth connection uses 2 COM ports, one for transmission and the other for reception. HC05 needs a constant power supply of 3.6 to 6 volt to maintain connection. No separate program is needed to be written for each Arduino setup. Multiplexing can be done for better usage of GPIO pins to accommodate multiple devices under a signal connection. In this pictorial representation, as you can see, our system is controlled by voice. We have basically used two machine learning models, namely local regression and k-nearest neighbor. Using KNN, we have built the advanced reminder system. With the help of local regression, we predict the temperature and sunrise-sunset time period to automate the AC, heater and the outdoor lights respectively. All the actuators used in our system will be connected via Bluetooth. As you can see, the Bluetooth controls the AC, heater as well as the outdoor lights. Our project has the following limitations. Predictive analysis is based on probability, so it can never achieve 100% accuracy. At times, the unpredictable changes in weather might increase the margin of error in the model. Larger dataset provides more promising predictions. Huge amount of data needs to be processed and it also needs to be updated annually to keep the model's predictions up to date. From this we can conclude that we have accomplished the following objectives. Sensors transmitting repetitive data are reduced and those values are predicted through machine learning model leading to energy and data storage conservation. Users do not need to set any reminder by themselves, thus reducing human interference. Each remote device is identified through its Bluetooth address. Hence, the signals will reach its destination without any cross-connection. The use of machine learning algorithms shall create noticeable differences in the overall energy consumption of the house. The system is able to understand the owner's actions and customize itself according to their needs. I would like to conclude by saying that we have been able to successfully complete our project and we hope to work further in this domain and bring more technological aspects to this project. We are grateful to our institute and our teachers for providing us the opportunity to work on this project. Through this, we have been able to gain knowledge on various domains like machine learning, deep learning, digital image processing, etc. Thank you.